I'm live. Welcome back. Welcome to the live Q&A for the 5 p.m. Q&A for 115, CSE 115. Today we're going to be discussing using JSON and actually getting web connections in Python. This is actually going to become very important in a few in the project in a few days. We're going to be working with other sorts of things. Clear this off. So, like I said, this is supposed to be a Q&A, a question answer period. If you have any questions, please feel free to type them out in the chat. I actually am monitoring that as much as I can. I've tried to make a few changes to keep this as simultaneous as possible. We'll see how well that works. So just to begin, I did want to point out that, we talked in the lecture, in the videos, about how we can use all this stuff we use these JSON, called JSON blobs. That is the technical term, is a blob. How we can use that to be able to transmit data over the web. But of course, that isn't the only way that we can use JSON blobs. It's unusual to use JSON inside of an application, but it is totally allowed. So just as a first sort of step, what I wanted to do is point out that I'm actually going to add to this. So what I'm using here is there's a special function built into Python called type, and it actually returns the type of a value. So what I have here is just a simple thing. So in order to use the JSON library, this is built into Python. We don't need to install anything, but we do need that import JSON statement. And then what I've done is defined here this string. It's just a simple Python string, but it does have some interesting behaviors, right? So it begins with that brace. It then uses a double quote. It's got to be a double quote for the letter A, and then has a colon, 45, not in quotes, comma, again in double quotes, B, colon, and then a lowercase t true, which, right, isn't the Python way. In Python, we'd use a capital T, and then the closing brace. So this is, on one hand, just a normal string, but of course, this also is a JSON blob. This is how we encode data using JSON as a normal string, but using these different things. So there is nothing wrong with me calling this next line here. I'm going to use JSON.loads. That's what we do. We give it a string. So the argument here is blob, that there. And it's going to convert it into the equivalent Python data. So just to show you all how this works, when I run this, what you can see is we're going to get a couple of different things. The first thing says, okay, this is using class stir. So this is the type of blob, right? Blob's value is a string. So that's what that's telling us. And the next thing, when we print it out, we get exactly what I had up here, just like you would expect, like we've been using in Python all along. But the next thing says, when we look at the value DIC, the value after we've called that has the result of that JSON.loads, after we've converted that JSON blob into usable Python data, you can see that DIC is a dictionary. Its type is not a string, it's a dictionary. So it's actually gone through and converted that JSON blob into something that we can use right away in Python. Beyond that, when I print out the dictionary, you can see that I get a regular dictionary. Note that the keys here now don't use the double quotes like I specified before, but single quotes just saying this is a normal string stir in Python. The 45 remains the number 45 because it wasn't in quotes. And now note that that true, which was in lowercase over here in the string, because that's how we write it in JavaScript, is in uppercase here in Python, because that's how we do it in Python. That's how the Boolean value, that Boolean literal, is written in Python. So we can and typically do use JSON as a way of transmitting data over the web, but there is nothing preventing us from using it just within a program. Now, in order to transfer it over the web, we'll have to make a web connection. And so what I'm going to do is actually get rid of all this. So one nice thing that you will be using fairly soon, excuse me, is we can actually, these import statements, right? We've used them so far to get modules that other people wrote that are built into Python or the bottle library, but we can actually use this on our own code. So if we want to use code that's in a Python file that isn't the one that we're in, so right now I want to use this code in reddit.py, I can just include import Reddit here, and Python will automatically go through, and when it runs it, it's going to run the code in this file. And you can see I'm going to close, just give us a little bit more space. What I'm going to do right here is sort of the second part of what we need to be able to do to transmit, or in this case, receive data over the web. Part of what we're going to use is JSON. The other thing that we're going to use is this URL lib.request module. So again, I need this import statement. This is built into Python. But what this is going to allow me to do is specify a URL, and that's, in this case, a web page. So I can actually show you, and hold on a second. I am not going to show you my personal Reddit account, but if we want, I can copy and paste this URL into the page and load it up. And you can see that what this is going to do is bring up all of the results, all of these the search page, the search results in Reddit for the name Matthew Hertz. Somebody has some interesting things. My personal recommendations after listening to 666 hours of podcasts, that's definitely not me. What if I told you South Dakota doesn't exist? Also not me. I always forget about the fact that there is a /r/Matthew Hertz dedicated page for all things about the man, the myth, the legend, Matthew Hertz. That one actually is about me. A student made that a while ago. It's a little disturbing, actually. But you can see that this is just a normal web page. Well, we can actually get the contents of that web page in Python. And the way that we're going to do that is it's a two-step process. The first thing that we have to do is make a connection to that web page. And the way that we do that is using this URL lib.request.url open. And when we do that, I'm actually going to use that type function again. It's going to give us a response, but it isn't actually going to give us the page. All that does is that makes the connection. And so you can see when I run this now, what it's going to respond with, the type of this response thing here, its type is an HTTP response. It's made a connection. It said, I've made the connection, I've gotten something back, but I haven't done anything with it. In order to be able to actually do anything with it, we need this next line. So we're going to take that variable. I happen to name it response. It could be named anything. And then we're going to call .read. And this actually reads in all of those results. But now there are lots of different ways that those results, they're going to be a string, but there are lots of different ways that could be encoded. If you look, I'm trying to remember where this is now. And now of course I can't find it. There used to be, and now that I'm looking for it, I'm not going to be able to find it. all sorts of different ways that you can do this in encodings. There are all sorts of different ways. So you can look, let me bring this up. This web page, for instance, is encoded using UTF-8. That is a one way of encoding text that's actually different than a string, which is what we usually use in Python. Python strings are primarily ASCII. So when we call that read, we're going to get a string back, but it may not be a string that we can read. So the last thing that we have to call is .decode. And what that does is that's going to figure out what kind of data that URL has and make sure that it turns it into and make sure that it can be understood by Python. And once we do that, once we read that in, I can then print out the response. And what we're going to get in this case is a huge amount of text. You can see it's still scrolling. It's going to continue to scroll for a long time. This is all of the text that is on that Reddit, that makes up that Reddit page. This is what our browser reads in. That browser I just showed you read in and rendered in order to show that nice page of results. So the thing about this is, and one thing I just sort of want to reinforce, as we're doing all of this, so here we have all of these different text and everything else. You know, all these web pages that we work with and we think are magic or we think are of as files or whatever else, really it's just a way of sharing strings over the internet. What makes it into a special web page and file and all that is how our browser handles that string. If our browser wants to say, well, let me analyze this like it's a JSON blob, then we can get usable Python data. If our browser says, well, let me render this and look at it this way, then we can look at it as a web page. It's really about how we try to handle it. From the perspective of the internet, it's just a string going across. From the perspective of the server, it's just a matter of what string they send over. They really don't have a difference here between those types of data. So this is a pretty simple example. Without revealing too much, you are going to be seeing this URL lib.request.url open function over and over and over again. And over and over and over again, what we're going to do is get that response. Here I happen to call it response. Could be called anything. It's just a variable. Python doesn't know the difference. And we're going to call .read.decode to get that string out, to get that string result. So just to give you another one, I'm going to go back to main, and we can look at Wikipedia. So one thing, there are lots of different sites out there that actually provide JSON responses. For this project, eventually, when you get to part 4, you'll discover that one of these locations, actually part 3 it might be, is the city of Buffalo. New York City also does this. Many cities do this. They all use the same basic system. I suspect it's just a commercial system they buy. But we can use all sorts of different things. Now, in order to know that it exists, in order to know how to do it, what you have to do is use the documentation. The pages that we're going to be using today are pages that I found. They're one of the primary aspects of them is, frankly, they're free. I didn't have to create an account. Makes it good for an example. But there are all sorts of different things. And if you look here is the API, the commands that we can use to work with the Wikipedia pages. Now, if you look, there are lots of different rules here, lots of different standards that we can follow. We can look at how to get a feed for on this day or for announcements. We can get it apparently get a page as a PDF. We can do some sort of math rendering, all sorts of different things like this. And the way that you learn how to use it as a programmer is you have to read through it. There's no other answer but just to read the documentation, read the API standards. So just as a start, I wanted to create a simple thing. I'm going to back this out real quick. Show you a very simple example. So earlier this semester, someone had asked about Heinrich Hertz, who was a German physicist, chemist. He's who the Hertz standard is named after. Also, my great-grandfather was named Heinrich Hertz, who also lived in Germany at the same time. My great-grandfather was a merchant. He owned like a general store, and not a particularly nice one if I understand the family lore properly. I'm not related to anyone famous other than possibly my father. If you're in either chemistry or the quality circles, you might know my father. But suppose I want to learn more about Heinrich Hertz. Well, we can get the Wikipedia page for that. The way that we do that is we have to use this, we have to go to the API, find out what to do. It turns out this URL will get us the page for the summary of the page for Heinrich Hertz. Now, in order to open up that data, we need to call URL lib.request.url open and pass the URL. I named the variable Hertz because it seemed to make sense. We then need to get that response and call read function .decode to get it as a string. And once we have that content string, if we look at the documentation, it actually sends it over as a JSON blob. So the actual string, once we convert it, what we're going to get is a very large dictionary. And we can print that out first. And you can see there's lots and lots of information there, most of which we don't want. The part of it that we really want is the extract. That is the key that we can use just to get a brief snippet of information. And remember, once we call JSON.loads, we get this as usable Python data. So if I run this, you can see that it's going to print out. Nerds can read this. I don't care. This is a computer science class, not a physics class, electrical engineering. I don't know, something. But this is part of the power of APIs, right? We can write a program now in Python that could get any information that we want out of Wikipedia. Suppose that we want to find out, there's always that on this day thing at the very top of the page. We could even get, by looking through that API, it turns out that we can find out on this day what's going on. Remember, none of these names mean anything. So here I happen to name the variable stupid name because I couldn't come up with something better. Again, I went through the documentation, births, deaths, holidays. I wanted to get birthdays. So I used /births and then the month and the day. So I used 0401 today. Once I have that URL, I have to use URL lib.request.url open to make that connection, to make that request. Use read, call the read decode functions to turn that into a string that Python understands. Now, if we go back here, what we're going to see is it's going to return a JSON blob. And the JSON blob, right, it responds a JSON containing all of the featured content. So that's what we're going to get back. And what it has is some responses. It's going to have all of these different values. So pages and all sorts of information. So just to show you what this looks like, if we then look at the births, so it is giving us all of the information about all of those births, their pages. Louis IV, called the Bavarian of the House of Wittenberg, was king of the Romans in 1314 and apparently born April 1st. Oh my God. Peter Hellendahl, in case you're curious, I butcher all names equally, was born there. Someone who probably doesn't have a page, Neil Lowentritt, who's my best friend growing up. He was born on April 1st. Happy birthday, Neil. You're not watching this. But you can see there's lots of different information. We can start to create again, if we wanted to include in a program, in a Python program we wrote, information from Python, who was born on a certain day, information about them, note that in addition to that extract about them, it has, the title, it has the year that they were born right here. It has references. We can find a link to that page. Now, that's kind of fun and interesting. We can do something slightly more scientific with it. So this is the example actually from the videos today, right? So the ISS, the International Space Station, is flying above the Earth. There is this other website, opennotify.org, which actually gives us the position and a constantly updating position of the International Space Station. So if we're ever curious where the International Space Station is. So again, I'm going to call that URL lib.request.urlopen. We always have to call that. That's how we make a request for information. I pass in the URL I need to use. I'm actually going to rename this because I just want to point out that this is a name. It doesn't have to be called response. I can name it where is the ISS? In order to get that JSON blob, to get that data, we need to call where is the ISS.read.decode. And that's going to give us that string. It is a JSON blob. So what we can do is then we need to call json.loads, pass in that string. That will give us usable Python data. And if we want, we can just see what that is. And so you can see that the data we get back is going to be a dictionary. It's got this key message, success, tells us it was successful. We have another key, ISS position, whose value is a dictionary. The keys of that dictionary are latitude and longitude, and then it has a timestamp. You'll note that latitude and longitude here are strings. They're inside of single quotes. The reason for this is that if we look at I'll comment this out, when that sends over data, you can see that those are numbers, but they're inside of double quotes. In a JSON blob, anything inside of double quotes will be interpreted and translated as a string, even if it contains a number. So why don't the TAs ever answer your Zoom calls? You first have to see if the TA is on call. The other thing is, if you're let into the room, it probably means they're working with somebody in a breakout room. We use breakout rooms in Zoom to answer them, but not what we're talking about right now. So the other thing it has is, like, if you look at this timestamp, its value, note, isn't in quotes. And so this is treated as a number. So if we want to not just print out everything, but actually work with individual pieces of that, we could print out where it is over the Earth, its longitude and latitude. And note that when I do this, I don't need that content string either. I got 164, whatever. Note that I didn't have to do a typecast to a stir. I didn't have to make it into a string because they already are strings. They look like numbers. They're not. For the numeric data, we can use them just like a number. So we can take that timestamp. The timestamp is the number of seconds since the beginning of its time. So if we take that and divide by 60 for 60 seconds in a minute, another 60 for 60 minutes in an hour, 24 for 24 hours in a day, that will tell you that day 0 for the timestamp that they're using in this JSON is, if I printed it out, it has been 18,353 days since they started their epic, since they started doing this. So very long time. I was gonna say, that's probably going to be January 1st, when I think about it, probably January 1st, 1970, which is to say older even than me. That's just a very common starting date for computer science. So again, this is something that we can use. And if we look, right, it was 168 and negative 42. Now it's 170 and -40. You can see that the International Space Station flies at a very, very fast rate, and that this data is continuously updated. So we could actually have a program that's continuously monitoring what's going on in, in this case, with the ISS. So again, useful for science, but suppose that we wanted to get into something even more interesting, like business. Look at this. So a last example I'm going to use is this one website. Again, how do I know it exists? How do I know to use it? I went to the web page. I read through the documentation. Nothing can get away from that. And what this website does is this is going to give us foreign currency exchange rates. So for those of you who are business majors or in the School of Management, for those of you thinking that business might be an interesting thing, this would be the way to handle it. This is a free service. It's provided by the European Central Bank. So by default, they use euros because Europe. But it actually allows you to look up all sorts of different exchange rate information. So here's this first example. So if we go to get the latest exchange rates for the euro, so here is the URL, this euro base. Again, I'm going to call URL lib.request.url open to get those exchange rates. In order to then look things, to read that response, right? That just gets a response object. We then have to call .read function, .decode, that gets it into a string. Now this response is going to be a JSON blob. So to get it to be usable data in Python, we have to call json.loads. And when we do that, what we're going to see is it's going to give us all of the exchange rates from any of these different currencies into euros. And if we want, we can see the different currencies they handle. So if we look at content, we can see it's got a key there, rates. And that rates is going to be an object right here, right? And all of those keys are the different currencies it handles. So if we call its .keys function, what we can see is that here are all the currencies it handles: Canadian dollars and Hong Kong dollars, and I'm not sure what ISK is. I'd have to read the documentation for that. There's US dollars, Great British pounds, Japanese yen. You get the idea. So this is one way that we could look up the current exchange rates if we're Americans, and last I checked, at least I am. Some of you are, not all of you, I realize. They actually do allow you to look up the exchange rates just for one currency. So if we wanted to look up the exchange rates for a US dollar, what we would have to do, and again, if we look and how to look through here, we can see that if we say go to latest, but add this query. So as we talked about with URLs, if we wanted to add a little bit more information, we do a question mark and then add key value pairs. So we're going to use a question mark and we're going to say base is USD. Base is assigned USD, US dollars. And again, once we have that URL, call URL lib.request.url open, say for America. We then read and decode that response, turn that JSON blob that it's going to send to us into usable Python data, and then we can look up the current rates for an American dollar. And you can see that if you have an American dollar, you've got 107 Japanese yen, 30. You could turn that into 33 Thai baht. I happen to know that currency. I don't know why. A little bit under a little bit more than 0.8 pounds, and so on. And so if we wanted, we could actually start to do all sorts of interesting things. Note that those are numbers, like you would expect. So we could actually try to write a program which will be able to allow us to convert between currencies. If we wanted to do even more, Another thing that this website happens to allow, that this will provide, is again, if you look, it can give you information about what's been going on. It actually keeps historical data going all the way back to 1990. So again, we have to just create that URL. The way that all of these things work, we make that request for a URL using urllib.request.urlopen, pass in the URL. And again, whether we're getting this is true whether we're getting a JSON blob back. This is true if we're getting a web page back, anything that we want. When we make that request, we then have to call .read.decode to get it to be a string that Python understands. Again, patterns there. Since this is going to be a JSON blob, and the reason we know this is because I read the documentation. There's no easy way to know about this. I'm going to call json.loads to get that content string into something that I can use in Python. And then if I print it out, what we can see are all of the exchange rates of the euro versus the Canadian dollar and the Thai baht for all the days between March 24th and March 31st. So we can actually see historical data for what's been going on. Oh, and this is against, I missed that. Base equals GBP against the British pound. And again, the way that if we have more than one part of our query string, we have the question mark to say URL's ending. Here's the query string. And then we have these key value pairs. Base is the key, GBP is the value. And then to say I want more than one, we use an ampersand. And so start at, and here's my value. End at, here's my value. And I want to compare the Great British Pound. The symbols that should be compared against are the Canadian dollar and the Thai baht. So any questions on using JSON, making requests of other web pages, anything like that so far? Okay, so since there are no other questions, one last example I'll just show you, just because I have it and I don't think I'm hiding anything. We can do basically the same sort of idea. Another place that makes data available is this blockchain.com. It's actually looked up the API right here. This is a very simple one. It just has a single page that it makes available. And what it's going to do is you can get information about the value of a Bitcoin. So if we want to look at the value of a Bitcoin in various currencies, you can see all of the different currencies it has. So $1 right now, you can buy some number of Bitcoins. So in US dollars, a Bitcoin right now goes for $6,366.51 if you're trying to buy or sell it. Apparently those are separated out, despite the fact that they're the same for everybody. But this gives you an idea if you're trying to buy Bitcoin or do anything with that, what you can do. You can also look at how many Bitcoins. What I'm going to do is I'm actually, just to show you that this is possible, we don't have to use a variable for the URL. We can just have a string hard-coded in there. That's perfectly okay. So I'm going to open this page, again, urllib.request.urlopen. I'm going to get that response called .read function, .decode as a function, turn that JSON blob into meaningful data. And what we're going to be able to see, in this case, it is sending over data as a JSON blob, but that blob is just a single number because for 500 euro, it turns out you can buy 0.08598569 Bitcoin. So another way that you can interact with this, they don't always have to be objects or anything else. Just going to get Python results. So there's lots and lots and lots of different sites available where you can play with this. if you look at the slides from today, at the end of the slides from today, I post a link to a page that has just lots of APIs, lots of sites that you can use to download information, typically as JSON, because that's how we do it on the web by and large. So you can experiment with your own. Sometimes they'll need accounts, sometimes they won't, but all sorts of interesting things. We will be doing this for the project. As we go on in the project, you will be needing to make connections to a City of Buffalo site in order to get things to work. So one thing to think about and one reason to get practice, also required for part of Module 3. So with that, does anybody have any other questions for me? Okay, it doesn't seem like anybody has any questions. So I'm going to say thank you all. Thank you for paying attention. Thank you for watching this. If you do have questions, remember Piazza office hours. We are trying to get to as many people as possible. Unfortunately, office hours right now more or less have to be one-on-one. So they, if you try to use Zoom or WebEx for me during my office hours, we may need to leave you by yourself for a little bit while we're working with other people. Please be aware we'll get there as soon as we can. And then just, have a good day, have a good tomorrow, stay safe, stay healthy, try to have some fun. Thank you all. Bye.